So we need the widths of all of the intervals, and the heights are going to be the height at 0, the height at 2, and the height at 4. So the widths of all of these intervals are 2, because that's the distance between the two numbers that you're going between. So the widths of all our rectangles, all of our intervals, is going to be 2. So I'm going to go ahead and just put that on the outside instead of writing 2 times something plus 2 times something plus 2 times something. If you want to put the 2 in front of each term because it helps you out, go right ahead. So what are the heights we're using? Oh, sorry. Nope, it should be 7, because -2. Oh, no, you're right. I was doing it in my brain, and I was, thinking about squared instead of cubed, so I was thinking that it, stays positive. No one can see that. That's way too thin. Thank you, Sam. So yeah, sorry, when you plug in -2, -2 cubed is -8, minus 1 is -9. I made it positive because I'm dumb. Thank you. So we need to use the values at 0, 2, and 4. So 0 is -1. And then we have to add that to the value at 2, which is 7, and then the value at 4, so 63. Let me figure out what this is, Sarah, and then I will answer that question in just a second. Let me just calculate this really quick. This will give you 138. So Sarah, the values are by 2 because, so we're asked to go between -2 and 4. So if you think about like the total distance we're spanning over a total distance of 6. -2 to 0 gets you the 2, and then 0 to 4 gets you 4, so distance of 6. And we want to break it up into 3 pieces. So if I'm taking a distance of 6 and breaking it up into 3 pieces, each of my pieces are going to have a distance of 2, because I need 3 pieces that add up to a distance of 6, so each one should have 2, which is why each of my subintervals should be 2. Distance of 2. Does that make sense, Sarah? Cool. My throat's dying already. Questions, concerns on how I got that? Is that a no to my questions, concerns? So let me do this. So then for the, so basically when you say 3 rectangles, it means 4. Okay. We're going from -2 to 4. Like that's what we're told to work over. So I need to split that into 3 pieces. So if we think about the total distance we have here. Oh, okay. I was really confused by why you said 4, Kayla. I'll have to think about that generically in a second. So the total distance we're working over is 6. So if you want to know the number of rectangles, or so I'm getting ahead of myself a little bit. Oh no, oh, no more space. I'll write this a little smaller. If you want to know the width or the number of rectangles, so there's 7 numbers, but the distance between -2 and 4 is 6. Like, so let me not write that. We're going between x equals -2 and x equals 4. So if you want to find the total distance, take your ending number minus your beginning number. So 4 minus -2 gives me 6. We're traveling over a total distance of 6. If you want to find the width of the intervals or the number of rectangles, there's essentially a relationship where you take the total distance, you divide it by one of them, it gives you the other. So if we're given the total amount of subintervals, so we're told that the number of rectangles is 3. That means we can find essentially the width of the intervals or the width of the rectangles by taking the total distance divided by the number of rectangles. It also works the opposite way. If you're given the width of the intervals, you can find how many rectangles you'll have by taking the total distance divided by the width. So you can always take the total distance that you're working over divided by the other number that you're given to find the other piece that you need. So since we're going over a total distance of 6 and we need 3 pieces, if you break 6 into 3 pieces, each piece has 2 in it. So we're going over distances of 2, so we need to go from -2 to 0 first, and then 0 to 2 and 2 to 4. If I was breaking this into, side note, if I was breaking this into 2 subintervals, total distance of 6 divided by 2 subintervals, that means my width is going to be 3. So in that case, I'd be going between -2 to 1, 1 to 4. I started second guessing myself a little bit because we only have 2 subintervals. So you do need to keep track of which is the number of intervals and which is the width. But in this case, if we wanted 2 subintervals, the width would be 3. So we'd break up -2 to 4 into 2 pieces, which means each piece needs to be a total distance of 3. If we were breaking it up into 6 subintervals, then you'd be going a width of 1. So you'd be going -2 to -1, -1 to 0, 1 to 2, 2 to 3, 3 to 4, and stopping. Is that making any more sense? So wait, hold on. Kayla, when I say 3 rectangles, it means 4 numbers. So does that work generically when I say? So I'm not loving you thinking about that way, Kayla, but it does technically work. If that is a good way to think about it for you. Juliana. Oh, you're just trying to also explain it. Thank you. Because you need to go over, so you only need 3 that. Okay, yeah, so yeah, I have kind of too many numbers in my table, if you will. I didn't need to use them all because of the right hand and the left hand sum. You only take however many values you're using in your rectangle. So if you're only using 3 rectangles, you should only add up 3 numbers. Very good point, Juliana. So let's try the left hand really quick. So the left hand, we're still breaking it up into 3 subintervals. We're still working over -2 to 0, 0 to 2, and 2 to 4. But now with the left hand sum, we want to use the values at -2, at 0, and at 2. The widths of all of the rectangles, the widths of all the subintervals are still 2. The value at -2 is -9 plus -1 plus 7. Hopefully I didn't miss any. So this comes out to be -6. Which is a huge difference, but if you look at the last value of 63, it kind of makes sense that that one was large and the other ones aren't. So there's obviously a huge gap between these 2 numbers, mainly because we're not using a lot of subintervals. The less subintervals you use, the worse the estimations are. Don't panic that the number is negative. It's okay. I know these are technically areas. We'll see in a couple sections later why it being negative actually makes sense in the math too. But also I just made this up off the top of my head. So don't panic that that's a negative number. Questions, concerns about that piece? I'll wait a couple seconds in case someone's typing. Okay. So, and here, so this one also talks about we have to split it up in kind of different ways. So hopefully that'll also help with the subinterval kind of questions that we were having. So we're given the following table and we want to do a left-hand sum. So this time we don't have to do both. We just have to do one in each case. We're asked to do 2 separate ones, but one in each case. For the given amount of subintervals over 0 to 30. So we want to take the entire interval from 0 to 30. But in the first case, we want to break it up into 3 subintervals. We're going over a total distance of 30 and we're breaking it up into 3 pieces. Each piece should have essentially a distance of 10. 30 divided by 3 is 10. So essentially the numbers we're going to be, well, the numbers we're going to be choosing from in the left-hand sum are going to be 0, 10, 20, and 30. Again, we're not going to use all of, why did that turn red? Anyway, we're not going to use all of them necessarily, but those are the ones we're going to choose between. Okay? So sometimes when you're given a table, you don't need to use all the values. Nudge, nudge, wink, wink. So we're going between 0 and 30. I want to break it up into 3 pieces. 30 divided by 3 gives me 10. So this is going to be my width of the subintervals. So I'm going between 0 and 10, 10 and 20, and 20 and 30. So those are the only values I will need to consider for this sum. Does that make sense, Victoria? So we need, yeah, need a left-hand sum. So the values we actually want to use, so again, the red ones I boxed are the choices that we have. We actually want to use 0, 10, and 20. So we're only using these first 3 values that are boxed. Since the width of all of the subintervals is 10, we're going to have a 10 on the outside, and then we're going to add up all of our widths, all of our heights, all of our heights. So the height at 0 is 10, the height at 10 is 13, and the height at 20 is 7. This is 300. Any more questions on how I got that? So we didn't have to do a right-hand side sum here, so we're done in that part. The next part wants us to do this a kind of same thing, but with 6 subintervals. So if we're still going all the way from 0 to 30, but we're breaking it into 6 pieces, 30 divided by 6 is 5, so the width of the subintervals are going to be 5. So essentially we're going to use all of these because we're going to go from 0 to 5, 5 to 10, and can I be lazy and do so on, and then 15, nope, 25 to 30. So I should be very careful with my phrasing. We're not going to use all of the numbers, but all of the numbers are the ones we are looking at to choose from. So you kind of need to break it up into like the numbers you're choosing from, and then actually pick the ones you need, depending on whether you're doing a right-hand or a left-hand sum. Victoria, we used the first 3 specifically because we were asked for a left-hand sum. If we were asked for a right-hand sum, we would have used the last 3 out of the ones that I had originally had boxed. So it depends on whether you're asked for a left-hand or a right-hand sum, which values you're actually using. If you're asked for a left-hand sum, you're essentially using the first from the left. And if you're asked for a right-hand sum, you're essentially using all the values on the right except the last one on the left. So we're breaking this up into 6 subintervals. So all of these numbers are our options to choose from, but we want a left-hand sum. So we're doing 0, 5, so on and so forth up to 25. So we're essentially using just this first batch. The width of the subintervals here is 5. So we're going to have 5 times 10 plus 5 plus 13 plus 2 plus 7 plus 15, which is something. $260. So for instance, say we wanted to do it again, but with 2 subintervals. I'm not going to actually write it down, but if we wanted to do 2 subintervals, you'd just be looking at 0, 15, and 30. And you would just use the first 2 values out of those. But you would split it up into 2 pieces from 0 to 15 and 15 to 30. So you always want to kind of figure out how the total distance you're working over, figure out how many pieces they want you to break it into, and that's going to be essentially, you take the total distance divided by the total amount of pieces they want you to break it into. That'll give you the width of each piece. Questions, concerns on that? The 10, 13, and the 7. So when I split it into my 3 pieces, I'm looking at 0 to 10, 10 to 20, and 20 to 30. And my left-hand side choices give me 10, 13, and 7 because those are my y values at the left end points of the intervals that I'm breaking it up into. So when I break it up into the intervals, I get 0 to 10, 10 to 20, 20 to 30. The left-hand side of those subintervals are 0, 10, and 20. So I take the y values at 0, 10, and yes, your quiz is just like this. Any more questions? Okay. Then I would like to finish 5-2. We have 2 more questions left in that thing of notes. Why isn't it letting me share it? Come on, Teams. Let me share it. Oh, sorry, Jeffrey. I didn't see that until right now. Well, I got to figure out why it's not letting me share this, so let me figure that out really quick. So I'll put that up for a couple more seconds. Did I scroll up? I did. Okay, good. I'll give you like 5 more seconds. Yeah, Jay, so I essentially do it on the outside because I'm super duper lazy. So the one that's up on the screen right now, that right-hand side, what I have would be equivalent to 2 times -1 plus 2 times 7 plus 2 times 63. So you can totally multiply those widths by each one of them separately. That's totally fine. You should get the same thing no matter what. I'm just lazy and I like to just start putting it on the outside when I can. So 5. Ooh. It's still not letting me share it, so let me just do this. All right. So we had 2 last questions in 5-2, so let's knock those out super quick. So we have a graph, and we want to know which of the numbers that they give us, 0.2, 0.023, 1.099, 1.526, and 11.984, could be the value of the integral from 1 to 3, and explain your reasoning. So remember, the integral is essentially, we defined it to be that really scary limit of the Riemann sums, essentially, but we can estimate the integral by using Riemann sums. So what we're going to do here is we want to go from 1 to 3, okay? Now, let me just think about a Riemann sum here, and let me take a really generic Riemann sum. Let me just take 1 rectangle in each piece, because it's actually going to start helping us eliminate some of these answers. So say take a rectangle with the height at that left side. So essentially my left-hand sum, if you will, if I just use 1 rectangle, well, we have a height of 1 and a width of 2. So 2 times 1 is 2. Note that that's going to be an overestimate because we're getting way too much area. And then what if I found the other side instead? What if I found the right-hand sum, again, with just one rectangle? So I'm taking the height to now be this right endpoint, which has a height of 1/3. So I still have a width of 2, but now I have a height of 1/3. Whoops. Which gives me 2/3, which is equivalent to 0.67 approximately. This is going to be an underestimate. Okay. So I'm kind of using these Riemann sums idea to get an idea of what kind of numbers I could be looking at. So notice that out of the 4 options I'm given, I have an 11.984, which is much larger than 2, and 2 is already an overestimate. So that one's out. That's like way too freaking large. If you want to write them, well, maybe I should like write them out down here again. 0.023, 1.009, 1.526, and 11.984. This one's out of the running because this is essentially greater than 2, which was our overestimate. And then the one in the very front, the 0.03, is less than our underestimate. So that one is less than 0.67. So if it's less than our underestimate, that's definitely not it either. So I'm kind of between these last two. Now, in general, if I were to just ask you this question on a quiz or an exam, which I don't think I would, but if I did, if you picked either of those two, I would probably call it perfectly fine. But if we think about it just the tiniest bit more, we can probably pick the better of the two. So remember, there's one other thing you can do with these estimates to get a better estimate, right? And that's you take the right hand and the left hand side and you average the two. And we called that the best estimate. So the best estimate here, let's take our two, kind of our right side and our left side sum, and let's average them. This is going to be approximately 1.3 repeating. So again, that kind of brings it down to what we kind of were already looking at. It's probably either of those two. They're pretty close. But now look at the graph and look at those rectangles that I've drawn on. Out of those two rectangles that I drew, it looks like the lower estimate is probably closer than the upper estimate. Like the amount of area that I'm missing in the underestimate looks to be less than the amount of area I'm missing in the upper estimate. So since the lower estimate seems to be kind of closer to the true value because I'm missing less area, if you will, it's probably going to be true that the actual estimate is going to be less than this. So since underestimate seems closer, actual value is probably less than this. Probably. So we would probably say the best guess we could give is this 1.009. Again, in general, if I asked you this question, if you chose either of those two 1-point things, I would probably just call it good. But if we think about it a little more and we kind of look at it, it does seem like the smaller of the estimate is probably going to be most likely the closer value. Does that make sense? Okay, I'm gonna stop here. I don't want to, but I'm going to because I think you'll need the time for your quiz. We'll finish that last question on Friday, then we'll go to 6-2. That last question won't take very long, but I don't necessarily want to rush it. So the quiz should be up on Blackboard already, and Let me get it to all like 2 of you that are here in person. So if you can turn on your webcam, let me take you, well, I'll take you off the big screen and stuff. Let me stop recording, turn on your webcams. I'm going to take you off the big screen, so don't